Hello, wonderful people. It's Medicosis Perfectionalis, where medicine makes perfect sense. Welcome back to my General Chemistry Quick Review playlist. In the last video, we had an introduction to chemistry, and we talked about how to tackle chemistry questions. Remember that students who are humble, who take their time, who solve every chemistry problem in a systematic fashion are more likely to get the answer correctly. But those who say, "Oh, I'm so smart, I can answer this in my head in 2 seconds," are more likely to be mistaken. Today, we have a very important topic, which is significant figures. This is very important if you're studying chemistry, physics, mathematics, biology, and much more. The digits in the beginning are called leading examples. These are leading zeros. How about at the end? Trailing zeros. How about in the middle? I call them sandwiched zeros. Please watch the videos in this General Chemistry Quick Review playlist in order. Let's start by answering the 2 questions of the previous video. Question 1. If A plus B equals C, and C is going to remain constant, and then A will go up, what's going to happen to B? Please pause and try to answer this yourself. And the answer is B will decrease. Because I've told you in the last video that when you have 2 entities added to one another or multiplied by one another, then the relationship between them is inverse, provided that the third entity remains the same. So if A goes up, B goes down. A goes down, B goes up. As Hillary Rodham Clinton once said, "When they go low, we go high." What the electorate did not understand was that she was referring to mathematical relationships. Maybe you're not convinced, so let's try this. Suppose that we say that 2 plus 3 equals 5, okay? Here we have 2 entities that are added to each other. If this 2 goes up and becomes 3, and the 5 remains constant, what do you think is going to happen to the 3? It has to decrease and become 2 so that you end up with the same 5. When this goes up, this goes down, and vice versa, because the sign between them is an addition or multiplication. Conversely, if the sign between them is division or subtraction, then they are directly correlated to one another. If this goes up, this goes up. So that was the first question. Second question, which graph, A, B, or C, has the highest compliance, knowing that compliance is the change in volume over change in pressure? Very cool. What did we say in the last video? The first thing in reading a graph is to look at the axes. I have pressure on the x-axis. I have volume on the y-axis. Next thing to do is to give me the slope. The slope here will refer to what? Rise over run. The change in volume to the change in pressure. So the slope is delta volume over delta pressure. And they already told me that delta volume over delta pressure is compliance. So the slope is the compliance. Now the next question is, which one of these curves has the highest slope, i.e., highest compliance? And one of the ways to get the slope is rise over run. The other method is tan the angle called theta. Where is theta? Theta is the angle that you make between the graph and the horizontal, not the vertical, the horizontal. And therefore, the theta angle for graph C is this, from here to here. How about the theta for graph B? Is all of this angle. How about for A? Is all of this angle. The bigger the angle, the bigger the tan of the angle, and the bigger the slope. So which one of these 3 graphs has the highest or the biggest angle? The answer is A. So A has the highest compliance, and B has an intermediate compliance, C has the lowest compliance. And now on to today's topic, significant figures. Some rules. The following are not significant. Number 1, all the leading zeros. Leading mean in the beginning, on the left. Look at these leading zeros, not significant. How about here, adding a decimal, still not significant. Okay, got it. No, you did not. If you just memorize rules, you will forget on your exam. However, if you understand why do we have these rules in the first place, you're more likely to get it right. Here's the thing. If I remove these zeros, 56, did the number change? No, this is 56 with the zeros or without the zeros. Zeros on the left do not count. Thank you so much. So are you convinced that these zeros do not count, i.e. not significant? Do you understand why? Yeah, I get it, because they are on the left. Okay, but hey, Medicosis, I don't get why these are not significant, because 0.056 is not the same as 56. Yes, that is correct. But let's imagine that this is 0.056 kilometers. Can we convert this to meters? Yes, indeed, since I know that 1 kilometer has 1,000 meters, therefore you can multiply by 1,000. When you're going from a bigger entity, kilometer, to a smaller entity, meter, you multiply. Or you can do dimensional analysis. Here is 0.056 kilometers. Okay, I want to cancel it with something, so I have to put kilometers downstairs so that they cancel one another. And I know that 1 kilometer is 1,000 meters. And then you do the math. 0.056 times 1,000 is, here 1, here's 2, here is 3 because I have 3 zeros here. So it becomes what? It becomes 56 meters, proving to you that I can live without these zeros. And that's why these zeros are not significant, because I can convert this into something else, rendering the zeros useless. That's why they're not significant. So that was the story of the leading zeros on the left. Moreover, trailing zeros on the right are not significant when they are merely placeholders. What does that mean? Same thing, if I told you that I have 5,000 meters of length, can we convert this into kilometers? Yeah, 5,000 meters equals 5 kilometers. So I can live without the zeros. They are not significant. If I told you that the distance from point A to point B is 5,600 centimeters, can we convert this into meters? Of course, 5,600 centimeters equals 56 meters, proving again that the zeros are not significant. Oh, by the way, let me give you a hint. A centi of anything is 1/100th of a thing. And that's why $1 has 100 cents. The word cent means 1/100th. So 1 cent is 1/100th of $1. How about the word deci, as in deciliter? It means 1/10th of a liter. Have you ever heard of the Roman centurion? Oh, he had 100 soldiers under his command. Next, spurious digits are not significant. What do you mean by spurious? I mean you're just guessing. Example, look at this lovely ruler. It's a metric ruler. Here is 1 centimeter, here is 2 centimeter, and then they give you these tiny lines in between. So here's 1.1, 1.2, 1.3, 1.4. So if something is 1.2 in length, then I'm sure it's here. Okay, but what if something is in the middle? Now, I've no way of knowing whether it's 1.23, 1.24, or 1.25. So I'm trying to guess. I am guessing on that last digit, deeming it insignificant. So the 1 is significant because it's measured. The 2 is significant because it's measured. How about 4? Not significant because it was a guess. Which means if one student told me this is 1.24 centimeters in length, another student said it's 1.23. Both are correct because both are guessing. But if a third student said it's actually 3.5 centimeters, no, that student is mistaken because the error was in the significant figures in this case. Next, the following are significant figures. The non-zero digits are significant. For example, 986. All of these digits are significant. So here we have 3 significant figures. Here's 1, another 1, a third one. You told us that the leading zeros are not significant and the trailing zeros are not significant. But how about a zero that's sandwiched between non-zero digits, as in 301? Oh, this is significant now because now try to remove it. I'll tell you, there is a big difference between 301 and 31. They are not the same. You can convert kilometers into meters. You can convert grams into kilograms. You can convert anything to anything. You cannot convert 301 into 31. It's not going to happen, which means this zero is significant. How about a zero following a decimal point and a natural, meaning counting number, like number 6? Oh, here's a 0. It's following a decimal point and it's following a counting natural number, 6. This 0 is significant, not just this 0, all of these. So here we have 5 significant figures. Here's 1, 2, 3, 4, 5. But look at this. Yes, the 0 is following a decimal point, but it's not following a natural number. It's not following a counting number. So all of these are not significant, only the 5 is significant in this number. Another rule. An exact number has an infinite number of significant figures. For example, if I know for a fact that there are only 5 students in the room, then 5, if written like this, is significant. If it's written like this, we have 2 significant figures. If it's written like this, we have 3 significant figures. You can add zeros to infinity. It will have an infinite number of significant figures. How about the famous pi? Oh, pi is 22/7, which equals 3.14, and then gazillion other numbers. All of these gazillion other numbers are significant, even if you have to write them to infinity. All of them are significant. A pearl for the pros. A 0 to the left of the first non-zero digit in a number with a decimal point is not significant. But if it's to the right, then it is significant. Can you give us examples? Sure. Let me give you examples of zeros to the left. How about 0.065? Well, these zeros are not significant. And why is that? Because this could be 0.065 kilograms. By multiplying by 1,000 to convert the kilograms into grams, you end up with 65 grams, proving that these zeros on the left are not significant. Conversely, if they are on the right and we have a decimal point, they are significant. Example, 6.500. These zeros are significant because when you write it like this, I'm assuming that you used your measuring tape or whatever instrument that you are using to give me this number. If it's measured, it is significant. But if you're just guessing at these zeros, then they're not significant. Quiz time. I'll ask you a bunch of questions, about 20 to be precise. With each one, I'd like you to tell me how many significant figures do we have, if we have any. And if we do have significant figures, tell me which ones. Let's go. 565. How many? With each one, I would like you to pause and try to answer yourself. Please pause. How many? Answer. 3 significant digits. 1, 2, and 3. Why? Because the non-zero digits are significant. How about this one? Please pause. The 5 is significant, the 6 is significant, but the trailing zeros are not significant. So we only have 2 significant figures here. How about this one? Oh, it should be easy. Only the 5 is significant. Trailing zeros are not significant because the 5,000 meters could be 5 kilometers. The zeros are not significant. How about this? Please pause. Oh, now we are cooking with gas. When you add a decimal point, you make these zeros significant. And that's the whole point of adding this point, to inform the reader, pay attention, I am rendering all of these significant. So here we have 4 significant figures. Try this one. What do you think? Leading zeros are not significant, so we only have the 5 and the 6, 2 significant figures. How about this one? Please pause. These zeros are not significant, only the 5 and the 6, because their zeros are to the left of the significant figure. And again, if this number is in kilometers, you can convert it into meters, and it will be 56 meters, and then the zeros are not significant. How about this one? Oh, that's easy. A zero that's sandwiched in between is significant. How about this? You can sandwich as many zeros as you want. All of them are significant. Look at this, look at this. How many significant figures? Answer, all of them. All 6 are significant figures. But if we did not have this decimal point, then I would have 5 significant figures and the 0 will be non-significant. Because when you write it like this with a decimal point, I'm assuming that you used your measuring device to measure this 50. It was not 49, it was not 51, it was 50. You actually measured it. That's why it's significant. But if you were just guessing, then the 0 is not significant. See, it actually makes sense once you understand what the flip you're talking about. How about this one? Please pause. Answer, all of these digits are significant. I have 6 significant figures here. Okie dokie, what's going to happen if I add an overbar or an overline? What does that mean? It means that this is the last significant figure and everything before it is significant. So I have 4 significant figures here. How about the zeros after the overbar? Not significant. How about an underline? Same exact thing. Significant, 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 and this is the last significant figure. How about this? Please pause. Well, when you write a decimal point and add zeros, and we have a natural, i.e. counting number before the decimal point, then these zeros are significant. So here I have 4 significant figures. When you write it like this, I know that you used your measuring device to actually measure 56.00. It was not 56.01, it was not 0.02, it was precisely 56.00. How about this one? Again, all of them are significant because they added the decimal point to inform the reader that these are significant. How about here? Answer. All of them are significant. So we have 6 significant figures. How about something crazy like this? 65,656,000,000. How many significant figures? Do not forget that all of the trailing zeros are not significant. So here I have 1, 2, 3, 4, 5 significant figures. But now look at this. 65,656,000,006. How many significant figures? Please pause. By changing the last zero into 6, you have made some sandwich action. And now, since these zeros are sandwiched between significant figures, non-zero numbers, then all of these zeros are significant. And guess what? Everything here is significant. So this has 11 significant figures. Go figure. Enough with these dad jokes. How about something like this? Well. Yes, we do have a decimal point, but all the zeros are to the left of the first non-zero digit. These zeros are not significant. Only the 5 is. Because let's suppose that 1 unit of x equals 10,000 units of y. Then by multiplying by 10,000, this zero will jump here and I will have 5, proving that these zeros are not significant. How about something like this? There is a decimal point, there is a natural counting number, and then we have zeros, which means all of them are significant. How about something written like this? 5.06 times 10 to the second power centimeters. Easy. First, try to convert this number into meters. All right, nice. I'll just ignore this. And I have 5.06 meters, which means whatever nonsense was here is not significant. The significant figures are these 3. Do you get the concept behind significant figures? Can we live without them or not? If you can live without them, they are not significant. But if they are essential, then they are significant. So here you have all the examples that we just discussed. Can you please pause and try to answer them yourself once again? I expect you to get more than 15 of them correctly. Let me know in the comment section how many of these you got right. Be honest. I trust you. And here are the answers. If they are colored in orange, they are significant. Anything else, not significant. And we just talked about all of these examples. For the pros, 56500 could have 3 significant figures, only 565, could have 4 significant figures, 5650, or could have 5 significant figures, the 5, the 6, the 5, the 0, and the 0, depending on the circumstances. What does that mean? If these zeros were estimated, just guessing, they are not significant. If the last zero was guessing, but everything before it was actually measured, then we have 4 significant figures. But if all of them are measured via a measuring device, then all of them are significant. So it depends on the circumstances. Okay, medicosis, all of this was about significant versus non-significant. But is there such a thing as more significant and less significant? Of course. Suppose that you wanted to buy a television. It was very expensive, $986. That was the price of today. If you went tomorrow and you find it $985 or $981, is this a big deal? No, it's not a big deal. It's a minor change. But if you go to the store tomorrow to find that this 9 became 1, so we have $186, is this a big change? Of course, that's a huge change. That's why this 9 digit is the most significant, because this 9 is counting hundreds, and the 8 is counting tens, and the 6 is counting ones. So the most significant, the intermediate significance, and the least significant, the lowest of the low. Some let them eat cake kind of a moment. In the next video, we shall talk about rounding to a certain number of significant figures. We'll also discuss scientific notation. Let me leave you with a question. Please round this number to 3 significant figures? Let me know your answer in the comment section. You will find the correct answer and explanation in the next video in this General Chemistry Quick Review playlist. Do you want more graphs in your life and more mathematical equations? Do you really want to understand pharmacokinetics and pharmacodynamics? Because this is how medications work in your body. I can help you with that. Just download my general pharmacology course at medicosisperfectionalis.com. It comes with videos, notes, questions, and answers. Do you want to know the side effects of aspirin toxicity? How about mercury poisoning, lead poisoning, cadmium poisoning, cobalt poisoning, etc.? Download my toxicology course. I have more than 1,400 free videos on this channel and more than 300 premium ones. You can get the premium ones by clicking the join button and choosing the highest tier. Thank you for watching. Please subscribe, hit the bell, smash like, support my channel here or here. If you want my notes, courses, cases, if you want tutoring, go to medicosisperfectionalis.com. Be safe, stay happy, study hard. It's Medicosis Perfectionalis, where medicine makes perfect sense. Well, medicine and chemistry.